All right, in the notes and learning goals, bullet point 6, you'll see that it gives this hierarchy. Now the hierarchy on there is drawn backwards of this, but I think it makes more sense in this way. The hierarchy is given on the notes and learning goals for the conversion assignment this way as well, with the little unknown in there, meaning that it's not entirely known. There's no way to really to just order things like this in this little spot here. Most engineering applications you'll find are either over here or over here. Mathematicians are concerned often with what's going on here because that's interesting to us. All right, so what is this symbol? It's just like less than, except for we're dealing with infinity here, and yeah. Okay. But you can think of it like that. All right, let's look at an example. Okay, here's bullet point 7. I'll do that problem. And then I'll do a few more examples the next video. Okay, now bullet point 6, what it says, just like in proper integrals, a series converges if its tail is thin enough. Series with fat tails converge, series with skinny tails converge. So the idea is that we're going to just look at the tail of this thing and compare it to a tail of one of these up here. Remember these are the ones that are that we know really well are converging. These are the ones that we know really well are diverging. And in later, in the convergence assignment, you may not be able to, you may not actually just see this series in here. You may have to kind of figure out where it sits. Okay. All right. Okay, so remember that this is AN. Okay. Okay, just write an A in there. Now let's pick out the dominant terms. We've got 5n squared over root 4n to the fifth. Let's see, that's 5n squared. That's 2n to the 5 halves. Remember that the constants don't really affect things much, so we can get rid of the constants. Think of this symbol as saying has about the same tail as that, and close enough of a tail that whatever we get here, if it converges, very similar to up there. Okay, so anyway, let's see. So let me just do a little review with the n squared over n to the 5 halves. You can do this, you can kind of deal with this in a couple different ways. I think the easiest is with exponent rules. You can say this is n to the 2 minus 5 halves. Or equivalently, you could do this is 1 over n to the 5 halves minus 2. Either way, you'll come out to the same thing. I'm just going to go with this one here. Let's see, 5 halves, that's 2.5. So 2.5 minus 2, that's a half. So it's 1 over into the half. Right. So the idea here is that this thing converges if it has a similar tail thickness, very close, has a tail thickness that's very close to the tail thickness of now you see this right there. Remember, these are divergent, so therefore, oops, this diverges.